Hello everyone, this is Arohi and welcome back to my channel Code with Arohi. In my today's tutorial, I'll teach you how to implement YOLO version 4, right? So whenever we work on any problem, the very first task is to prepare the dataset in the format which that particular algorithm accepts. So first of all, I'll teach you how to prepare your custom dataset in the format of YOLO version 4. This will be our first task. Second task is how to train your custom YOLO version v4 model, and then I'll show you how to test your algorithm, how it is performing, right? So to know that, we have to test our algorithm, so I'll tell you how to do that. And finally I'll tell you how to display the results, how to see the predictions, right? So this is what we are going to do in our today's class. So let's begin. See, if I talk about YOLO version 4, so this is the format which YOLO version v4 accepts, right? What is the format? First of all, it want a class name, right? Class name, whatever the class name is. First of all, it wants class name over here, and then these are the coordinates, x and y coordinates, and width and height of the object. This is what YOLO v4 model wants when it wants to perform the object detection task. So our task is, for preparing our dataset, our task is to convert your dataset in this format. All right. So how we can do that? Okay, see this picture over here. So you'll see over here, first of all, I have a picture with the name of 1, and then I have a text file with the same name, image name, and the text file name is similar, right? And then I have another image with the name of 2, and then I have a related text file with the name of 2 only. So in the same way for this third image also. So what I'm trying to say over here is, we are going to have image, and for every image we are going to have one text file. That text file will have the coordinates, will have the annotations of that particular image, right? So this 1.txt file is a file which will have the annotation detail which is related to the image 1. Okay, in the same way 2.txt file will have the annotation details which is associated with this 2.jpg image. All right, so for if you are having 1000 images, that means you're going to have 1000 text files, one text file for each image, right? And that text file is responsible for storing the annotation detail for that particular image. So this is what we want, right? So now, okay, one more thing. Let's suppose you have this image. This is 1.jpg image. Okay, let's say. So in this image, if we are having two objects, that means the related annotation file will have two separate coordinates for each object in separate lines. Okay, so this first line is for first object, and this second line detail, second annotation, is for the second image. So for example, if you have 4 objects in one image, that means you are going to have 4 different annotations, 4 different coordinates in 4 different lines, one line for one object, right? So this is these are just basics which I'm telling you before moving to the code. I'm just telling you the basics so that you can relate later on when I'll write code, then you can relate. Okay, so now we want to convert our dataset in the format of YOLO version v4. Okay, so for that, this is one tool, bbox label tool. So this tool is available on GitHub. You can directly download it from there, right? So I'll mention this this link in my description section. From there you can copy and clone this whole GitHub repository. So let me show you this repository first of all. So this is a repository, right? So you need to you can download this repository from here. Okay, and now when you will download this repository, see, what we want from this repository is, this is basically a bbox label tool. This is a tool, desktop tool. Using this tool, we are going to annotate our images in the format of YOLO version v4. Okay, so so as I've just told you, this is a desktop application. So if you want to run desktop application on your device, then you need to install Kinter first of all. So just open your command prompt and execute this command, pip install tk. TK stands for Kinter. Okay, so Kinter is a module in Python using which you can run desktop applications. So if you already have this in your PC, that's okay. But if you don't have this, see these command, the above command will show you the results only if you have this Kinter module in your Python. So just install it. Okay. Once you install the Kinter, why we are installing Kinter? Because we want to use this bounding box tool, which will, which will annotate all our images in the format of YOLO version 4, right? Which will annotate our images. So for running those files, we need this Kinter. Okay. So this is the first step. First of all, install Kinter. Now you already have downloaded this code and you have installed this. Okay. Now the next step is create one folder. Okay, so what I'm saying here is just create one folder. For example, I'm here and I'm creating one folder over here with the name of YOLO demo, right? So just create one folder like this, and under this folder, now whatever I'm going to teach you, you have to do all that functionality in this folder only. So the very first thing is create 3 folders: images folder, labels folder, and examples folder. Create these 3 folders under this YOLO demo folder. Okay, so over here you need to create 3 folders, right? So one folder name should be images, other would be labels, and third one would be examples, like this: images, labels, and examples. Why we need these 3 folders? And guys, remember, names should be similar to this only, because these 3 folder names are going to be used by that bounding box tool, okay, which will annotate your images. That tool will work according to these folders only. So have these folders only with the similar names. Okay, so now under YOLO demo folder you have these 3 folders: images, labels, and examples. All right, now the next task is under images folder. Under this images folder, now create folders as per your classes. Let's suppose you want to build a object detector which can detect 2 separate objects. So for example, you want to build an object detector which can detect laptop and phone. So laptop is one object and phone is another object. So what I want is, I want to build an object detector which can detect 2 objects. So for every object you need to create a separate folder under this images folder. Okay, so let's suppose if you want to build an object detector which can detect 100 different objects, so that means over here you need to create 100 different folders, one folder for each object. So for our today's example, I'm going to build an object detector which can detect whether the object is phone or laptop. So for 2 objects only, I want to build an object detector for 2 classes. Okay, so that's why I have 2 separate folders under images. Okay, now under images you have created 2 folders. In the same way, for labels folder, remember we have created 3 folders: images folder and labels folder and examples folder. Under images folder you have to create separate folder for each object, and under labels folder also you have to create 2 folders for separate objects. For under images and under labels, you have, in both the folders you have to create these 2 folders: phones and laptop. Okay, so After that, the next step is, see, now we are going to use that we are going to use that bounding box tool for annotation. So okay, let me open my code first of all. So here is my code. See guys, this bbox underscore tool, convert.py, right, and this process.py. These are the three files which we need from that GitHub repository. Okay, the bounding box tool GitHub. When you'll download that repository, from that repository, just copy these three files. Which one? First one is bbox tool, and then the other one is convert.py, the last one is process.py. Just copy these three things from that bbox tool folder and paste it in the folder which I've just shown you. Okay, so where is the folder? It is in our downloads. So under YOLO demo folder, over here paste these three folders. Okay, bbox tool, convert, and process.py file. So from where we got these three files? We got these three files from the bounding box tool, right? So paste it over here, and these are the, okay, let me rename these folders also, labels, and the last one is examples, right? So now you have these many folders and files in your folder, in the folder in which we are working. Now let's annotate our images. So for that you have to run this particular file first of all, bbox underscore tool. Okay, so I'm running here. You need to open command prompt and enter in a folder where you have this code. So my code is in D drive, so I'm running over there only. So over here, just write python bbox tool.py. When you will enter, so this kind of tool you'll get. See, so this is a desktop application. Now over here, image directory, and then we have an option of browse over here. Just click on this option and then go to the folder where you have your images. So guys, if you want to build an object detector which can detect images, which can detect images of laptop and phone, that means first of all you have to store some images in those folders. So remember images folder. So under this images folder you have to create two folders. I have told you that a few minutes back only. So I already have that code over here. Under images folder, create two folder, laptop and phone, and under laptop folder paste few pictures of laptops. You can download those pictures from internet and paste it over here. Okay, and under phone also, so let me show you. I have images folder. Under images folder I have laptop folder, and under laptop folder I have put laptop pictures. See guys, I'm using very less images because I have to I'm just going to explain you the concept, but for better result obviously you need to have lots of images to train your algorithm. So over here store images of laptops, and under phone store images of phones. Alright, after downloading the images here, now we want to annotate these images. So for that we have this bounding box too, right? So I'm going and I'm selecting a folder. You need to select the folder of the particular object where you want to perform this annotations. Okay, so I'm choosing the laptop folder, select folder. So laptop folder got selected, and the very first images we can see the very first image over here. Okay, so this is the very first image. Now you have to plot a bounding box. So just drag and drop like this, and when you'll enter you'll get the bounding boxes coordinates over here. First is x and y, and next is height and width of the image. Okay, now over here we have a button of next. Just click on next. When you click on next, you'll get a next image from that folder. Just drag and leave it. You'll get the annotations related to that image, and then again click to next and drag the image like this, and then next. So I was just having 3 images and in that particular folder, so my work is completed. After performing this, you will get separate text file for each image. So now let me show you the folder. So this was the folder, laptop folder. See, earlier I was just having the images, but now I'm having a text file related to each object. When you'll open this text file, you'll get the bounding box coordinates of that particular object. This is what we want, right? So this is the first object. This is the first task. Now what we did is we first of all downloaded the images related to every object from internet, and then using this bbox tool, using this bounding box tool like this, we have opened a bounding box desktop application, and then we have plotted a bounding boxes on it, right? So this is what we did. So after that you'll get these kind of text files for each object. Okay, now the next task is, after this, the next task is, now what we'll do is, see guys, remember I have told you in the very beginning of our today's lecture that YOLO version v4 wants, this is the format which YOLO version v4 accepts. Now we have just got this much, x, y, width and height. Remember we just when you'll open here, okay, so we are getting 4 coordinates here, but we are not getting the class name, whether that coordinate belongs to phone class or a laptop class. We didn't get the class name now, right? So now using the convert.py file. So from where we get this convert.py file? So guys, for this I have told you these 3 files. We have copied these 3 files from the bounding box toolkit which we have downloaded from GitHub. So we have this convert.py file over there only. So right. So the next task is open that convert.py file. Right. This convert.py file will help us converting those text files in the format of this way, the class name and then x, y, w and height, width and height, which this YOLO accepts. So let's open that convert.py file now. Okay, so let's open that convert.py file. So this is my convert.py file. So what you have to do is, first of all, in this line number 13, I have written laptop and phone. You have to mention your custom class names over here. So if you are having 50 classes, you have to mention 50 classes over here, exactly the same. This is case sensitive. Okay, so write your class names over here, and after that scroll down and below this configure path. So you can see what I have done is, this my path variable is commented and another my path variable is not commented. So what I'm trying to say over here is, see, for every object this file will run one time. You cannot convert the format, you cannot convert all the files of all the classes at one time. You have to perform the functionality object wise. This convert.py file, at one time it will convert the it will work for one object only, right? So first of all we will work for laptop class, and after that we'll comment the code which is related to laptop class, and then we'll run this file convert.py file again for phone class. So this is what I did here. See, my path, under this my path variable, labels, and then we have laptop. Okay guys, before moving to this step, let me tell you one more thing. Okay, so we were here. So we have performed this much step, right? Under laptop you have images of laptop and the related text files, and under phone, you have the images related to phone and their related text files. After that, what you need to do is copy all the text files manually, right? So the images, the text files which are related to phone class, copy all the text files from here, and under labels, we have this laptop and phone folder. Just ignore the other folders right now. Just as I've told you, just create two folders only under labels, which is laptop and phone. Okay. So under phone folder, copy all the text files, paste all the text files which you have copied from the phone folder of images folder. Okay. And under this labels folder, label folder under this laptop folder, copy all the text files which is in images folder, laptop folder over here. Copy all the text files of laptops from this image folder and paste it in the labels laptop folder. Okay, so now we have pasted all the text files in a separate folders under labels folder, right? So class text files which are related to laptop should be in the laptop folder, which is under label folder, and the text files which are related to phone should be in the phone folder under label folder. Okay, after that we will work on this convert.py file. Okay, so what we are doing over here is my path, labels, and phone. So what we are trying to, which path is this? We are giving a path of our text files because we want to change the format of our text file. So this is what we are doing. Under label we have phone folder, and under phone what we have? Text files of text file which are related to the phone images, which is in the images folder. Okay, so same way under my path we have given the path of labels and output path. Now what we are doing is create two more folders, right? Now under this label folder, create two more folders. One folder name should be output underscore laptop and other folder name should be output underscore phone. Okay, this is what you need to do. After creating this output underscore laptop folder and output underscore phone folder, let's move to the code again. So why we have created these two separate folders again? Output underscore laptop folder will store the annotation files for each image in the format of YOLO v4, means the class name, XY coordinates, and then the width height. And outputs underscore phone folder will store the final annotation file which is in the YOLO v4 format, class name, XY coordinates, and the width and height of that image object. Okay, so first of all we'll run this convert.py file for our phone object, and after running that file once, after that we'll run it for the laptop folder. So right now under my path we have given the path of text files which are related to phone, and output path we have mentioned that we want to store the converted text files at this particular path. Okay, so the final output text file we want to store at this location, which would be in the format of YOLO version 4. This change you have to do this and this. After that, that's it, nothing else to do. This will save your files. Okay, so after doing these changes, just run the code here. Just write python convert.py, right? Python convert.py and enter. What will happen? Under this output underscore phone folder, you'll get these text files. Now when you'll open these text files, you can see one is the class name and these are the bounding box coordinates. Okay, so once you done it for once you run this file for phones.py, after that what you need to do is you have to run the same file for laptop. So now comment the code which is related to phone and uncomment the code which is related to laptop, right? You need to do these changes only and run this convert.py file again from your CMD. Once you run this file, you will get, okay, so you under this output underscore laptop folder, you will get the new text file which will be in the format of YOLO version v4. Let me open this file and show you. See, 0 is the class name and then the bounding box coordinates related to that, right? So this is how this convert.py file work. So you can see here, see, this is the text file. Text file looks like before running the convert.py file, and this is the text file you get after running that convert.py file. Over here we have class name and then the bounding box coordinates, right? Now our data set is ready, right? Okay, now the next step is you have this images, labels and examples folder. Now create one more folder here with the name of multiple images. You can create it with any name, right? So I'm creating it with multiple images. So where you have to create this folder? Over here, right? New folder and just give it a name, multiple underscore images. What you need to do over here? You need to copy all the images which are in your image folder, which are related to, you know, laptop or phone. All the images related to all your object. Copy all those images from your images folder and paste it here. And all the text files which are in output underscore laptop folder and output underscore phones folder, copy all those text files and paste it over here. What I'm trying to say over here is copy everything over here, means all the text files related to all objects, right? And all the images related to all objects, paste them in this multiple images folder. Let me show you my multiple images folder. Okay, give me a minute please. So here I have a folder with the name of multiple images. Open it. So you'll see all the images with their text files over here. This is the final step. Now our data is ready. Skip this step for now, the last step. This step will execute later on. Now our data set is ready. Okay, so what we have done is we have downloaded the images from internet, and then using bbox tool we have annotated our images, and using the convert.py file we have converted our images, their annotation text files, in the format of YOLO version v4. And what is the format of YOLO version v4? This is the format of YOLO version v4. This is what we are having. And finally we have one folder with the name of multiple images. That folder is having our data set, all the images and all the text files, right? So now let's see what to do next. The next task is to train your YOLO algorithm. Now let's move to that. So guys, now our data set is ready. So now for this execution of YOLO version v4 for training and for testing, I'm going to use Google Colab, right? So what you can do is just go to your drive, click on drive, right? And then when you click on new, you'll get options like this, and when you'll click on more, so you will see options over here. So from here just click on Google Colab. So this is how you will get your notebook. Okay, so here we are going to write our code. Now when you open your Google Colab notebook, over here under edit, just go for notebook settings, and from notebook settings just check this GPU and then save. This is just you need to do at the very beginning, right? Now let's go back to our code. So guys, under your Google Drive here, just create one folder. Okay, so we are creating one folder over here. So I'm giving that folder name is YOLO V4 Pi4. This is my folder. Under this folder on my Google Drive, I'm going to write all my code. Okay, so I'm here. Now in this YOLO V4 Pi4 folder, I need one notebook, Google Colab, right, where I'm going to execute my code. The same, just click on new and then more and then, oh sorry, this was a mistake. So just click on new, more and Google Colab, right? So we have opened this notebook. Over here we are going to execute the code which we need in our which we need for training our algorithm, right? I have opened this code. Now here the very first thing which you need to do is just these lines. So what this line is, we are mounting our Google Drive. I'm just copying it from here and I'm pasting it here, right? And then shift enter will execute your present cell and will give you a new cell also. So this is how you mounted it. And after that, the next step is this. This step simply means, see, this is the address of your drive, but there is no need to write this whole address. You can just write my drive instead of writing this whole thing. So if you get this kind of thing, then just click on this link and you will get one authorization code from there. Just copy it and paste it here and then shift enter again. Now let's run this cell. And what is the purpose of this cell? This cell simply means, okay, this cell executed once, so that's why it's giving me error when I executed it again. So what will happen with this cell? That simply means you can write this instead of giving your whole drive address. Okay. After that, the next step is, now let's move into the folder. What's our folder name? YOLO V4 Pi4. Just cd YOLO V4 Pi4. Okay. So we have entered in a folder now where we are going to write all our code, right? So what we have done is we have created one folder, and under that folder we have our Google Colab notebook where we are writing a code, and we have mounted our drive and we have entered in the folder. Now the next step is to download the darknet framework, and you can download this darknet framework directly by cloning this GitHub. So I have written this and then shift enter. After executing this command, under your YOLO V4 folder, you will get one folder with the name of darknet folder, right? So we have a darknet folder now. So next step is, okay, so the next step is, just give me a second. This. So first of all, we have entered in a darknet folder, and in a darknet folder we have a make file. So we want to do few changes in that make file. And what are those changes? See, in our make file, before this slash, this is the thing which is already written in a make file, and this is the new code which we want to update this. We want to update the make file where OpenCV value is 0. We want to update it with the OpenCV is equal to 1, right? So this 0 means we are not using OpenCV, but we want to use OpenCV. So that's why OpenCV is equal to 1. And in the default settings of makefile, GPU value is 0 and we want to write 1 because we are going to use GPU for the execution. And this is again CUDNN was 0 and we have to make it 1. And in the same way, these are the other things which you need to do. Okay, so these are the changes which I want to do in my makefile, and I've written those changes over here. And after that, press enter. Now the next thing is to run your makefile. So how we can run a makefile? Just write this. This command will create a new makefile. Okay, means this will update that makefile. Okay, so we are executing it. It will take some time. After that, what you need to do is let it get executed. It will take few more seconds. So once this command got once this execution once this execution got run, after that the next thing is this. What is this? We want to download the YOLO v4 weights. So this is the link from GitHub LXEAV. From there only we are downloading these weights. So guys, on a GitHub LXEAB, right? So from there I'm copying the required files like YOLO v4 weights and these kind of things, right? So okay, makefile app completed its task. So now the next thing is to download these weights. So now I'm executing this command to downloading the YOLO v4 weights. So once this YOLO v4 weight, we got these YOLO v4 weight. After that, I'm changing the permission, because if you'll not change the permission, you'll get a permission denied error. So we are changing the permission. So we have changed the permission for darknet folder. Now the next thing is, okay, this is important now. Python process.py file. So guys, if you remember from this YOLO demo folder, I have shown you what to do with convert.py and bboxtool.py file. But we have another file with the name of process.py file. That file we are going to use over here. But before working on this file, right now, see, we have our dataset and we have the text files and everything we have, right? So now our task is to copy all those things on a Google Drive. Then only our code will execute. Then only our algorithm will execute the results, right? So now comes to this YOLO v4 pivot folder, and under this folder we have this darknet folder. Open this darknet folder. From this darknet folder, over here we have one CFG folder. Open this CFG folder. When you will open the CFG folder, you will see you have lots of CFG configuration files over here. And when you will scroll down, in the last line in the last few lines. Okay, one file you'll see over here, YOLO v4 custom.cfg. We only need this file. Just delete everything else because we only need to work on this file. Okay, so I have already I have this file downloaded. So what I'm doing is I'm uninstalling, I'm deleting everything from this folder. Everything. This CFG folder is blank, but you need to have that file, YOLO custom.cfg file. Okay, now over here under this CFG folder I have that file. Okay, let me open that file. Uh, just give me a second, guys. YOLO before particular deep learning. So from here in darknet folder under CFG folder I have that file. I have already created that file. So let me open this file and show you what to do. I have opened this file, right? So from where you will get this file? So from under darknet folder you have a CFG folder. Under that CFG folder there are lots of files, but you have one file with this name, YOLO v4-custom.cfg. Just not delete this file. Apart from this file, delete everything else, right? Then in this file we have to make few changes, and those changes are this batch. Let me show you the changes, what changes you need to do. So the very first thing is change batch 1 to 64. Means over here what we want is, we want 64 over here, and subdivisions we want is 16. You need to do these changes manually. Okay, so batches are 64, subdivisions are 16, and this is the image size. Channel 3 means we are working on colored images, and after that max batches. Now this is the important thing. So what are the important parameters? You have to change batch, you have to change subdivisions to 16, and after that come to this max batches. Now the important thing over here is the minimum value for max batches is 6000, right? So basically what the thing is, usually let's suppose if you have one class, then max batches would be 6000. If you are working on two classes, then again max batches would be 6000. And if you are working on three classes, then again max batches would be 6000. But if you are working on more than three classes, then you need to follow this formula. What this formula is, see, when you will open max batches, you will get this value 500500. Okay, this is the by default value when you will open this CFG file. Now max batches should be 6000 if you are using one class, two class, or three classes. But if you are using more than three classes, then you need to follow this calculation for the max batches. Let's suppose if you are using four classes, then 4 into 2000. Okay, and if you are using five different, you want to build a class object detector which can detect 5 different classes, then over here how many different classes you are using? 5. Then 5 into 2000, that would be 10,000. Okay, what would be the max batches if you are having 5 different classes? Over here you have to define 10,000. But in our case, how many classes we are using? We are building an object detector which can detect phone and laptop. That means we are having two classes. And for two classes, one class, two class, or three classes, we are going to use max batch is equal to 6,000. So that's why I'm writing this over here. And under steps, this is again important. Steps simply means you have to write two steps over here. One step, comma, this is the second step. first step should be the value, means what should be the 80% of 6000? 4800. And what would be the 90% of 6000? 5400. You have to mention that 80% of your max steps, and over here you have to mention the value which is 90% of your max step. This is the other change which you need to do. After that, these are the changes. After that, just find Control F and write YOLO. So you are getting YOLO over here. So we are having three different YOLO layers. So this is the first YOLO layer. So just above the YOLO layer, you have activation and then the filters. By default, these filters would be 255 when you work on your CFG file, right? Why I have written 21 over here? Because how many classes we have? See, change filters from 255 to filter 21 in our case where we are having two classes. These filters would be different for different classes, okay? And this is the maths you need to perform for it. Classes plus 5. How many classes we have? Laptop and phone, 2 classes. Plus 5 is 7. 7 into 3 is 21. So that's why we are having 21 filters over here. And let's suppose if you are having one class, that means 1 plus 5 is 6. 6 into 3 is 18. Then how many filters you are going to have? 18. And don't change other filter values. You have to change the filter value which is just above the YOLO layer. And we have 3 YOLO layers, and after above every YOLO layer we have this filter, and you have to change the filter value for every filter which is above the YOLO. Okay, so we have changed it to 21, and below this YOLO, under classes, over here by default you would be having 80, right? But you have to change it as per your object detector. How many classes we have in our object detector? So we are having 2 classes, so that's why I have written 2 over here. Now find next. So when we find next, again you can see we have another filter over here. Change the value to 21 because 2 plus 5 is 7 and 7 into 3 is 21. And over here again change the classes. Find next. For third layer also change the filters. Change the filter over here and change the class over here. So these are the changes you have to make in your YOLO v4 custom.cfg file. And this file, we will put this file, where to put this file? Under the CFG folder. Okay. So now let me upload this particular file from here. Upload files, and let me from darknet CFG, I'm uploading this file over here, right? So now what we have in our CFG folder? YOLO v4 custom.cfg file. Now come out from this CFG folder and you have one data folder. Open this data folder. You have to delete everything from here except this labels folder. Remember, don't delete this labels folder. Apart from this, delete everything. So I'm deleting whatever is there in this folder, right? So what we have in a data folder? Labels. And now remember, over here you have to paste the folder where you have all your images, right? So let me upload it. Darknet folder, and this is my data folder. From there, okay, this is not the example which I'm looking for. Give me a second, guys. So okay, just come to my drive. Actually, I have already executed this code, so if I'll upload all those things again, so that will take time. So I have already have those things. So let me open this YOLO v4 underscore custom folder, right? Over here I have executed already that code under this folder. So see, we have darknet folder. Under darknet folder We have CFG folder. Under CFG folder, I have that YOLO v4 custom.cfg file, which I have just shown you how to do it, the work on it. Now come out from that CFG folder. So this is my data folder. Under this data folder, see, this is the label folder which I have told you not to delete. So don't delete that folder. Alright. Now I have another folder with the name of pyfood. So this is the folder where I have all my images and their related text files. So guys, what all these images are and text files are? These are the images and the text files which we have stored in here. Let me open this file, YOLO demo, under this multiple underscore images. Okay, so this is the folder I have uploaded, right? So the folder name is pyfood in my case, so you can write any name over there. So this is the pyfood folder. Under this pyfood folder, I have all the images and the text files which we have created using that bbox bounding box tool. Okay, so paste all your images in a folder, and after that, remember the folder name over here, and after that guys, you have to create pyfood.data and pyfood.names, these two files. Let me open these files and show you. Let me download it, and let's download the other file also. Now let's open pyfood.names file. Under pyfood.names file, what it is, we are having the name of our object, name of our classes, and one class name should be in one line. For every object you need to write in a separate line. So laptop and phone. What is there in pyfood.names? Laptop and phone. And let's open this pyfood.data. Pyfood.data will tell you how many classes we have. 2 classes. And this train and valid, what it is. See guys, now if you want to train your algorithm, so you have to divide your data into train and test. On training data, we will train our algorithm, and on test data, we will test the functionality of our algorithm. So this is what we are saying. What we are saying is, under data folder, we need a train.txt file which will have the details of data which we will be using for training purpose. And under data folder, we need one test.txt file. So basically this train.txt and this test.txt file will create these files by running this process.py. So guys, remember I've told you, like, we'll execute this step later. So that train.txt file and test.txt file, you will get those files after executing this code. Okay, so right now what I'm telling you is that in pyfood.data, what we have written is, we are telling that we have 2 classes, and for training data, this is the file to follow, and to test our algorithm, this is the file. And where are the name of classes stored? Name of our classes are in pyfood.names, which is in data folder. And this backup, this is a very important thing. And backup, this is a backup folder. Now let me show you first of all what I'm trying to say. See, we are in data folder, right? So pyfood.name, pyfood.data, test.txt, train.txt, everything should be in data folder. This test.txt and train.txt you will get after executing this code, right? This you have to create yourself. Just open Notepad and just write pyfood.data and just enter the data which I have told you. Just enter all these things and open pyfood.names, okay, and just write the object names, right? This you have to create it yourself. Train.txt and test.txt will get created when you will execute process.py file. Okay, now let's come out from this data folder. Over here you can see the backup folder. This backup folder you'll get it when you'll install darknet. This will be there only. In this backup folder, these are the different weights when you will train your algorithm. So the weights of your trained model will get stored over here, and using these weight files we will test our algorithm later on. Okay, so backup folder is a folder when you execute the command to train your algorithm. So this is the place where all the trained weights will get stored. Using these trained weights we will test our custom detector. Okay, all right, so this is what I was telling you. So clear about what we have in our what we have over here, pyfo.data and pyfo.name you will create. This will get created itself, and in backup folder we'll get our backup files. Okay, now let's move to the code again. Okay guys, one more thing. Oh no, right. So now come here and let's execute this file, python process.py file. So when you'll execute this file, so right now we are getting error because I hadn't uploaded the folder over there. So you just need to execute this command. After, just do control enter, and after that when you will open your data folder, over there you will get this train and text.py file. Okay, so now how to train your algorithm. So this is the command which you need to write. So this is the command. Let me paste this command here. So what we are saying is, this is the command, exclamation symbol dot slash darknet detector. Train is to train our train the algorithm. What we are saying is, you need to give the path of your .data file. So our pyfo.data file is in data folder. And then where is our configuration file? So remember, under CFG folder we have this configuration file where we have made our changes, and then these are the weights which we have installed, right? And when you'll execute this command, this will take time. Training will take time, 30 minutes, 40 minutes. It depends, right? So what you can do is, after some time you can check your backup folder. This backup folder will store the weights after every 1000 epochs. So this is the 1000 epoch. This weight is for first 1000 epoch. This is for 2000 epochs. These weights are trained on 3000 epochs. Means after every epoch you will get this, right? And YOLO v for custom best and YOLO v for custom last. So these are the different trained weights, right? So under backup you will get it. And let's suppose if you are training and in between you want to stop that training process, you can check your backup folder. If you have this weights file over here, then you can stop the process and you can use any of the weight file from here to test your algorithm. Okay, so after this, training part is done. Okay, now we want to test our algorithm. Now when you want to test your algorithm, then again you have to make changes in this file. For training, what we did for training is, we made change the batches to 64. But when you want to test, just write it 1 over here, and subdivision is also 1. That's it. You have to make these changes. And how you can make these changes? By this command. So what I'm doing is, I'm entering in CFG folder, and this was the previous value of in this particular file. 64 was the previous value for batch, but now I want to update it with the 1 because we want to test our model. And again, in YOLO v4.custom.cfg file, earlier subdivisions were 16, but now I want to do it as 1. And after making the changes, just come out from that CFG folder and execute the command to test your algorithm. So this is the command which will test your algorithm, darknet detector test. Again you have to write this whole command. Threshold 0.3 simply means minimum threshold value should be minimum that we need this minimum accuracy required for this algorithm should be 0.3%. Okay, so this will test part will run, and after that this I am show only this much. This is the extra code. Let me delete it. So this is the simple Python function for showing the prediction. So what we are doing is we are importing CV2 and matplotlib, and then we are reading the image, right? We are storing the height and width in a separate variable, and then we are resizing that image, and then we are plotting that image, right? This is the function. So you can, now what we are doing is we are calling that function. I am show is the function name, right? I am show is the function name, and this predictions.jpg is the predicted image, right? So whenever you will test your YOLO v4 algorithm, the latest result, the latest predicted output will get stored in this predictions.jpg, and over here you can see the prediction. So guys, in my case I'm not getting the predicted result. Why? Because I have used only 10 images for laptop and 10 images for testing my 10 images of laptop and 10 images of phone. This is very small data set, so that's why I'm not getting the proper result. Even I have stopped my training process in between, and so that's why I'm not getting proper result. But this is how you can execute the whole program, right? So just remember, we are using the bbox tool to annotate our images, and we are uploading everything on a darknet. And guys, don't worry, what I'll do is I'll share this whole code which I've explained you. I'll share each and everything on my GitHub, and that link is given in description section. You can download that code and try it yourself. So thank you guys.